Hello everyone, in this recap video, I'm just going to quickly go over how we can use our graphing calculator in order to solve for an equation. The first method we're looking at is by using the intersection method. So let's just have a quick review of what we looked at in class here. Here I've got an equation with two parts, the part in green and the part in purple. The part in green and the part in purple are equal to each other. In that sense, you have two functions. Let's call the one in green function 1, and the one in purple, the number 2, is function 2. Even though it's just a number, okay? If they're on two sides of the equation, we call them function 1 and function 2. And what we will want to do on our graphing calculators is to graph them as function 1 and function 2. Here's our result. I'm just going to quickly go over those steps again here. We start by adding a graph, and for my first function, I will write out function 3 divided by x plus 1. Now note that x plus 1 is one factor or one entire divisor, so make sure you're putting brackets around that if you're using the division symbol. But if you don't want to use the division symbol, you can also use the fraction symbol. So I'm going to go ahead and add plus, and I'm going to use the fraction model here. And my fraction I'm adding is 1 over x minus 1, 1 over x minus 1. Okay, so just make sure you do that. If your plus 1 and minus 1 are outside of these brackets, for example, it looks like that, you're going to get a completely different equation. And here's my first graph. For my second graph, I'm going to press tab and f2x, my second function, I'm going to put in 2, which is on the right side of my equation, and there you go. Here are my two graphs. What you want to do in order to find the value of x is use the intersection function. And I can visually see that I've got two intersections. Here's my first one, where the x value is 0. And remember, the x value is the one we want to solve for, not the y value. And I'm going to go to Analyze Graph again and use intersection on the other one. And you can see here the x value is 2. Looking at our two coordinates, x then must be equal to 0 and 2 in this particular equation in order for this to be true. Now let's look at a second method. This is the x-intercept method, or you can call this method finding the zeros of the function. And remember, you have found zeros of the function previously in our units. We're using the same equation, but in order to find zeros, we actually need one side of the equation to equal 0, not 2. So how do we do that? Well, we are going to minus the 2 from the left-hand side of the equation. So we're simply moving the 2 over, and now one side is actually equal to 0. And you will have just one equation to put into your calculator, and that's this one. Now, unfortunately, your textbook does have an error here. It tells you to graph this particular function, but as you can probably notice, it is missing something. If you said it is missing the minus 2 we just looked at, you are absolutely correct. So please make a change to your equation. That should say minus 2. Otherwise, the equation is completely wrong. Let's go back to our calculator and I'll just show you what that graph looks like. First, I'm pressing tab. I press up to go up to function 2, and I'm going to delete function 2. Now I press tab again. I'm going back to function 1, and this is just so that I don't have to retype the entire function. But I'm going to put in a minus 2. Do you want to pause the video and try following that? All right, now I hope everyone is on the same page. We're going to press enter. And there you have it. You may have noticed that your graph has actually shifted downwards by exactly 2 units. And that's what this minus 2 will do for you. It is shifting your graph downwards by 2 units. Okay, so now that you've shifted your graph down, we don't have to use the intersect function. We're actually going to use the 0 function in your calculator. Now we're going to highlight this section. We have 0, 0. And you can probably guess that if I go to analyze graph and 0 on my other 0, so my other x-intercept, I will get 2, 0. Zooming into our graph here, again, the solutions we're looking for are always x values, and that means x is equal to 0 and x is equal to 2. The exact same answer we found by using method 1.